Alright guys, welcome back here today to the S63B44 build, serial number 0179. We've completed the block here. We've done the lapping with the silicone compound to bring out the roughness and the cylinder bores, and we've checked those with a profilometer, so that's all good. We've done the ring gaps, and we've matched the rings to each cylinder. Remember, when you take your bore readings, you're going to have deviations in your cylinders, and when you put your rings in, you'll have a little deviations in your ring gaps of each cylinder. So to maximize the ring gaps, you kind of move the rings around to each cylinder to match it, so you get the optimum ring gap. So that was done. That's why we have these rings labeled with the appropriate cylinders. We've got our crankshaft that's standing straight up. This is ready to install. We'll keep it like this so we don't have any undue bend in the crankshaft from lying flat. Our block here is clean and ready to go. Over here we've got our rotating components that we're in the process of weighing. The rotating components per cylinder consist of the rods, new bolts, new connecting rod bolts, piston rings, clip, new Axial race bearings, and your piston with your wrist pin. Right now that assembly, that's number one, that's 1122 grams. So when this crankshaft went out, this crankshaft was internally balanced. What that means is that when this went out, I sent out one rod, one piston, one new set of rings, one new set of bearings, and new bolts, and along with the wrist pin and the clip, so they can mark that up as a weight and they've duplicated that weight for each of the cylinders. So you've got 8 cylinders. 8 was duplicated as the weight on this crankshaft when they balanced it. So this crankshaft is balanced to match one cylinder components. We are checking each of the cylinder rotating components and getting the grammage from each of them. We are trying to keep the difference in grammage between each cylinder to a minimum, as close to zero as possible. Why we're trying to do that is because we're trying to minimize or eliminate any internal engine vibrational imbalance. Okay, so we're going to weigh each one of them, all 8 cylinders. We're going to get the grammage, and then we're going to I'll plug that into one of my formula spreadsheets, and we'll try to maximize how we can try to maximize the grammage around each cylinder. We've got a little bit of things that we can play with to try to change those grams. We've got the piston rings, individual sets. You may have a gram or two, not even, maybe a gram difference that you may find. You've got your Axial bearings, maybe a gram or half a gram difference that you may be able to change. Your bolts, maybe your bolts have a 1 or a gram, half a gram or 1 gram difference that you're going to want to change. Your piston with your wrist pin may have 1 to 2 grams difference. So if it comes down to that, we've got to change pistons around to other cylinders with to match the connecting rods, we'll go ahead and do that and just make sure that that piston still matches with our bore for the piston to wall clearances. So that's number 1. Let's check number 5. So this is number 5 that we just did here. You guys can see this is exactly what we want, right? So number 5, rod, new Axial bearings, new rings, wrist pin clip. Number 5, piston with the wrist pin, new bolts. And we're right at the same grammage, 1122. And that's exactly what we want. Okay, so right now we're going to go ahead and weigh the others, and then we are going to start the piston to rod assembly. Okay, a little bit more of an illustration of what we're trying to achieve here. So your crank, cylinder 1 and 5 is on one journal, and 180 degree away is cylinder 4 and 8. So you've got to make sure that what I'm trying to do is that both of these, the rotating assembly, the rod, the pistons, the rings, the bearings, wrist pin, all of that, that the total grammage on the zero, consider this your zero position, the total grams at here is equal to the total grams at 180. Okay, so therefore at 0 and 180 you negate the imbalance if there's any grammage. There's a certain amount that's allowable, but I try to aim for 0. So, and then similarly 6 and 2 and 7 and 3, they're 180 apart. So again, you're trying to get the difference between the rotating assembly here and here, try to get it to 0 or as close to 0 as possible. In this particular engine, we had a deviation of 6 grams between two positions, 0 and 180. So we had to, the imbalance or the excessive grammage came from the pistons with the wrist pins. So we switched those pistons around to the other cylinders to minimize the amount of imbalance, and while at the same time making sure that those pistons, it's got the correct wall to piston clearance in the bore. Okay, so we are finished with our ring gaps and all of that. We are finished weighing all our cylinders, all our pistons and our rotating components. Now we're going to assemble our pistons to our rods, put our rings on, install our crankshaft, check our breakaway torque and rolling resistance, and also do our Plastiguage check on our main bearings. So let's get to that. We are back here, starting with our continued build. So we've got all 8 of the pistons. We've assembled the rods to the pistons, installed the rings. These pistons and rings are all ready to go, matched up the connecting rod bearings. So next up, we're going to go ahead and install our King's main bearings and install our crankshaft. So first part, we're going to install the bearings and we'll check our Plastiguage check to see our clearance. You guys can see the all looks pretty good. closer to 1.5 mil, 0.0015, which is good. Alright, we're going to go ahead and install the oil spray nozzles, the piston spray nozzles. Okay. You guys remember we cleaned these, we blow air through it, get all the contaminants out, make sure the check valves were working. Okay. Piston nozzles are in. Now we're going to put the crank back in, and we are going to check all our clearances on our crank, all our dimensional on our cranks. You know, end play, breakaway torque, rolling resistance, run out of the crank. So first thing I'm going to do, I'm going to put it in, bolt it up, and then we'll start to check the rolling resistance. The last thing I'm going to do, I'm going to check the run out on this. Okay. Alright, time to check our crankshaft axial clearance. Okay, so axial clearance is the amount that your thrust bearing controls. So your thrust bearing is located on number 3 right there. You can see it's got a thrust bearing on the side. See here, this is your thrust bearing on the side here. So you're trying to check the clearance as the crank goes this way, how much it's moving axially. Okay.
Alright, so we've just finished the runout inspection on the crankshaft with the three journals in the center, the two supported here, and we'll check in the bend in the crankshaft, how much that crankshaft bends. There's a tolerance criteria, so we've just gone ahead and checked that. It's important to note that you'll have a plus and a minus. So you know, as the crankshaft is bent like this here, you know, you will have a plus reading. If the crankshaft is humped like this here, you'll have a minus reading. So you'll sometimes, as you're going across at different degree positions, you'll have a plus and minus, and those has to be taken into account when you're taking in the eccentric mass and the balancing of the crankshaft. So bottom line is, we've gone ahead and checked the run out on the journals, and they're within BMW criteria, so this is good to go. Okay, so next step, what we're going to do to remove the crankshaft, we'll put the bearings back in, we'll lube it up with some assembly lube, get the crank back in there, install the main caps, and we'll start to torque those down. Okay. Alright, so we've got the crankshaft in. We've got our molybdenum assembly lube, lower main bearings. Crankshaft is all set, rotates nicely. Okay, now we're going to go put our main bearing caps on. All our caps have been lubricated with the molybdenum assembly lube as well. Alright, so we've installed the crankshaft. We've just loosely installed the main cap bolts. So now we're going to go ahead and initially torque these 20 Newton meters. All through the installation, I was checking my rotation, make sure that I've got no binding and this rotates pretty nicely, which it does, looking at my breakaway torque and my rolling resistance. We'll continue to do that as we torque these down to make sure that there's no binding. If there's one cap or anything like that that's create a binding, we know where that is. Okay, so initial torque 20 Newton meters. Alright, so we've got the crank all locked up, torqued it, full torque, 20 Newton meter plus 120, plus 100 degrees. I just went and checked my crank axial clearance with the top cap on now, and I'm tight, under spec, so I'm gonna have to go ahead and remove the caps, remove the crank, and do some work on that thrust bearing on number, where is it, number 3, so we can have some increased axial clearance on the crankshaft. So just one of those items you have to continually keep checking on your builds, you know. It was good with my lower cap, but once you put your upper cap on, it was not good. And even with the lower cap, it was right at the minimum. So I kind of figured that I would have to do it, but I was hoping that I didn't. But anyway, crank's coming back out. We'll do a little work on that thrust bearing to remove some material, and then put it back in and make sure that we get our thrust clearance of our crankshaft within the required BMW specification. All right. Hey guys, round 2 of the crank installation. So we got the crank all installed. You guys saw that video, or I hope you did. Got the crank all installed, button up the top, and then our axial clearance was low, was on the spec. So I had to take all the caps off, had to take the crank out. I had to adjust the thrust axial clearance bearing. Had to adjust. This is your thrust bearing on your main bearings here, right? I had to adjust this to allow for my crank to move more. I didn't have enough movement. And then on top of that, once we start to adjust it, we found that we had movement without the caps installed. But when we put the caps installed, I lost maybe 2,000 or 3,000. So there's an adjustment on the bottom, adjustment on the top. So bottom line, we're ready to go back together. So we're starting from fresh here. Bearings are installed, cleaned. Crank is here. We'll clean those bearings up, we'll put them back in. So let's get the crank installed. Lessons learned, guys. These are the moments that when it happens and you're all buttoned up and you got to take everything apart, don't back away. This is what's going to make your build a longevity build and a quality build. Get the specs right. Get it done right the first time. All right, we've torqued the main cap bolts. Visually, you can see they're angle torqued, 100 degrees. Visual indication, so that's good. These are all torqued. We checked our breakaway torque on our rolling resistance. We're well within spec. We're happy about that. We check our axial clearance. Crankshaft moving this way, and we're right within the minimum spec, above the minimum spec, which is acceptable, which we weren't before. Now we're going to go ahead and install our M8 bearing cap bolts here. Okay, these are 10 Newton meters plus 55 degrees. Okay. Okay, next we're going to go ahead and torque our threaded support sleeves. Okay, these are 6 Newton meters. Alright, so we're going to go ahead and torque the threaded support screw connections to the block. These are for the oil pump supports. So we're going to go ahead and torque these down now. 34 Newton meters. Alright guys, crank is installed and fully torqued down. We've got our main bolts that we torqued, 20 Newton meters, then 100 degrees. Visually we can see that we've got our angle torque, all of them. Okay, next we've got our cap M8 bolts. Those were 10 Newton meters and 55 degrees. Again, angle, you can see visually they all match up with the angle that they were torqued. Then we torqued our threaded support sleeves, 6 Newton meter to seat it to the block, all of them, all 10. So you've got a nice support to the block. And then we've installed our screws here, which we torqued to 34 Newton meters. These three here holds the oil pump, so same torque on these to 34 Newton meters. Then we checked our rolling resistance and breakaway torque. That's still good, not a problem. So this crank is good to go. Next, we're going to go ahead and start to install our pistons and check our connecting rod bearing clearances. Okay? Leave me a comment, guys. Tell me what you think. Thanks.